So welcome everyone. Just give me a minute. So welcome everyone to this problem solving session, week number 9 of this course titled as Sensors and Actuators. My name is Shomnath Bhattacharjee, and this is a brief details about me. I am currently pursuing my PhD in the Department of Electrical Engineering, IIT Jodhpur. I am working towards development of flexible and organic transistors for neuromorphic computing applications. And like I take this class on every Sunday from 6 to 8. And this is the last part of this course where I have already completed eight, like we all have completed 8 weeks of this course. And so like this is the ninth module of this course, which is at the last half of this course. And so like throughout this course what we have learned is that we have learned about sensors, actuators, transducers, and further we have learned how to fabricate them, and then through fabrication what kind of a materials do we use, what kind of a protocol do we need to follow, and everything. So then afterwards we have learned about like different techniques like photolithography, and then further we have learned about patterning. Apart from these patterning techniques, we have learned about how to deposit our material, how to deposit our oxide layers and everything through thermal evaporation, through e-beam evaporation, through sputtering and these things. And then we have learned about these different kind of equipments and how the chamber works, and what kind of a pressure do we need, like why do we need plasma and these kind of a things. In the last week we have learned a little bit about photolithography, which I have already covered in my previous classes, so that's why I didn't drove into like more detailed studies and everything. So in this class what we'll learn is that the cancer diagnostic test. I'm not gonna detail about those things because it has been already detailed like with a very preciseness in the course itself, and there are several Arduino based applications. So in this what I'll do is that I'll like as in the course itself, in the course the main demonstration was towards a demonstration of sensors, that was like the pressure or the force sensor. So I'll talk about that as well, but I'll also talk about some other sensors as well. If we'll have a discussion about those things, then we'll also move on to this stepper motor that already has been discussed in the course. Then I'll talk about that a bit, and then we'll talk about other actuators as well, and how these kind of actuators are different. So one of the most easiest to learn sensor is obviously pressure sensor, that is the piezo resistive one, not the piezoelectric one. There are other type of sensors as well, that like there are triboelectronanogenerators or TENG sensors as well, so I'll talk about that a bit. And then for the actuators, one of the most easiest one are the DC motors and the stepper motors. So we'll also discuss about that, how a DC motor is a bit different from the stepper motor, and what kind of a stepper motors are there. So in the course what we have learned is based on the shaft, that the rotor shaft. So we had some different kind of the course, along with that the types of windings. But we'll also learn about what is brushless and brushed, because in the course there was not much like deeper discussion of that, and why synchronous and asynchronous motors and those kind of a things. But at first we need to know that in the course itself, the first thing was that recap of clean room protocols. But as I have discussed it very like just a second, yeah. So as this point was discussed in my earlier lectures, so I won't go into these details. If anybody have any questions regarding this clean room protocols, the clean room equipments, or the clean room process and these things, you can ask me. Otherwise, I guess in which one was that? In the second class and in the third class, I have already discussed about them. So like you can check that out. Otherwise, you can, if you have any queries, you can ask me obviously. But apart from that, we are not going into that detail. And other things were like we'll have the example of sensors and actuators that is exactly same as the course itself. So for the first one, what we'll do is that we know that in the course itself we have learned about this pressure and force sensors. So now this pressure and force sensors, so there are like different kind of a pressure and force sensors. So one of the two most easiest ones are the piezo resistive one, the piezo electric one. So these are the most two easiest force or pressure sensors. Now for this force and oh, okay, that's fine. Okay, let's do one thing. So this piezoresistive one based on resistive phenomena, whereas the piezoelectric one is based on generation of electricity through how what is the process. I'll describe that later. So in this case, the piezoresistive sensor, the first one is this one is a piezoresistive. Now in this, just a second. Let me do one thing. Yeah. Now, in the piezoresistive sensor, what happens is that through mechanical deformation, through mechanical deformation, this thing moves like this. Just let me check the thing. Yeah, everything is fine. Through mechanical deformation, like by bending it or something like that, based on that, there's a change of resistance, and that is how this pressure sensor works. So based on mechanical deformations, through like applied force or applied pressure and everything, this sensor works. Now for the piezoelectric one, what happens is that with the force or the pressure applied on top of it, it changes its size. Let's say the previous one was here, now this have decreased. Now based on that, what happens is that it will create voltage, and through this the piezo electric through the piezoelectric effect, the piezo electric sensor works. So apart from that, we also have a newer generation of pressure sensors. Those are known as the TENGs, TENG, or tribo electro nano generators. So the main thing, this is a more advanced one, but we don't know. We don't need to go deeper into this type of nano generator or nano generative sensors or something like that. But the basic thing with this is that the STENGS works on the triboelectric effect. So we have this piezoresistive effect, we have this piezoelectric effect, but this triboelectric effect is through tanks. We utilize this triboelectric effect, which gives a more higher response. So, if we need to compare those values generated through that, is like if through the piezoelectric effect we get a 5 volt or a 6 volt output, that is enough for an Arduino or something to work on. But if we need a much higher response than that, so we need something that generates a much higher response. So that's why this triboelectro nanogenerators comes in. They are nano generative of the electricity. So we have like small nanogenerators that generate this electricity, and this provides, let's say, this is just a basic estimation. So if the piezoelectric effect gives you just gives you a 5 volt or a 6 volt response, this triboelectric effect gives you at least 60 or 80 volts output. So that's the basic difference between a triboelectric nanogenerator and a piezoelectric and piezoelectric effect, or piezoelectric nanogenerators. Even there are PENGs as well, PENGs, that is piezoelectric nanogenerators. So this is the basic understanding of different kind of force sensors. Nowadays people have been researching on these things and everything, but the basic thing are the piezoresistive and the piezoelectric effect. Okay, now, so like as we have already gotten many things from that, the basic principle is, like, I can write it here maybe. So the basic principle is obviously P equals to F cos theta A. That is, if we have, let's say, an area like this, and the force is applied at this point. If the applied force is F, if we draw a perpendicular and this is the angle of this applied force, then this is, and the area of this is A, so then the applied pressure would be P equals to F cos theta by A. So that is the basic sense of these sensors, how they work. And now, so like in the course itself we have already learned about two different kind of pressures. So that are the barometric and the, sorry, just a second, barometric pressure and manometric pressure. So to measure the barometric pressure, we use the equipment that is known as the barometer. That is a well-known equipment to measure any kind of atmospheric pressure. And for the manometric pressure, we use the manometer. Another name of this barometric pressure is, as I was saying, that atmospheric pressure. So to measure any kind of a, let me write it down first. So, so this is also known as the atmospheric pressure, and this is also known as the gauge pressure. Now, the basic thing to understand is that what is atmospheric pressure? That is amount of pressure applied onto any kind of object or something like that. So let me write it down first. Pressure applied to any object that is in an atmosphere. So in that atmosphere, if we even if so the water pressure is also a kind of atmospheric pressure, where we put a material inside or put a object inside, let's say my phone. So if I put my phone inside water, and it experiences pressure from the atmosphere, that the water atmosphere, it is also an atmospheric pressure. But a barometer often is used to measure the atmospheric pressure, like inside the room, inside let's say a lab or something like that. So barometer does that. So a basic and let's say the basic unit is pascals, that is PA. But at sea level and at room temperature, that is nearly 25 degrees C, any object experiences a pressure that is 101.325 kilopascals. So that is a standard atmospheric pressure, and we also, which is also one atmospheric pressure, or 1 atm. So one atmospheric pressure is 101.325 kilopascals. Now for manometer, what is this? Manometer is the gauge pressure. What is gauge pressure? That is the internal pressure of any system. So, and this is not anyways connected to the barometric pressure or the atmospheric pressure. So what happens in inside a system, if you have a small ecosystem or something like that, if you have any kind of equipment inside that, you have a very like let's say inside your PC you have your RAM, right? So if the RAM feels any kind of a pressure from the system itself, not from the atmosphere, but from the system itself, that is the internal pressure of that system, and like it is also part of that system, but it feels pressure from the system. So this is called the gauge pressure or the manometric pressure. Now, to understand the total pressure experienced by an object. So the total pressure, let me write down. Total pressure experienced by an object will be the barometric pressure BP with manometric pressure. Also another thing to note is that manometric pressure can also be negative as well. So this is the total amount of pressure, that is the also known as the absolute pressure. It is also known as the absolute pressure. So this absolute pressure is nothing but the addition of, or let me write it down. Absolute pressure is nothing but the addition of BP plus MP. MP can be negative, so the total atmospheric pressure can be less on the object than it seems. So if it's let's say it is put inside a system, but it experiences less pressure than the atmosphere itself. Okay. Now, apart from that, there were like several gas laws as well. I'll not go into that detail, but the basic equations that govern this kind of a thing are V equals to CT, that is a Charles law. Then P equals to A by V, that is the Boyle's law, and PV equals to nRT, that is the ideal gas law. So here in this term, that is the total volume of the like based on this, so this pressure are measured for the gases and everything. So in the experiment and everything, like the demonstration of the experiment, we have already learned about these kind of things, so I am not going into that detail. But if you have any kind of a question on this pressure sensor, so we'll move on to other type of sensors as well. If you have any questions, you can ask me now. So let me talk, just a second. So yeah. Talking about different kind of sensors apart from this, like as it was detailed in the course itself, so I was talking about this. But apart from this, pressure sensors, so there are so many different kind of sensors, right? So there are gas sensors, there are physical sensors, like let's say apart from this, so you have the like if you want to measure the velocity, if you want to measure the acceleration and these kind of things, if you want to measure the physical movement of something. So there are several different kind of sensors. There are different kind of chemical sensors, gas sensors. So these are similar kind of sensors. Apart from that, there are physical sensors that that measures any kind of a movement or any kind of physical activity or these kind of things, right? So, um, like anybody of you can talk about different kind of a sensor. Just name a different kind of a sensor that is not a pressure sensor. So like I wanted to discuss any different kind of a sensor because there is not only this pressure sensors or something like that, right? There are several different kind of sensors, like there are temperature sensors, there are several different kind of a things.
Ultrasonic sensors,
Yeah,
vibration sensors.
yeah. So ultrasonic sensors. So these are also position based sensors. So these comes under the physical sensors. So ultrasonic, and any different kind of a position sensors. So what does ultrasonic do?
It helps to measure the distance between the sensor and any one of.
So overall, it helps us to like point the position of that sensor, right? Now, apart from that, like let me know about any different kind of a position sensors that can be used as like to estimation of the position itself. There's a question.
Gyroscope, sir.
Yeah. Any other? So these are normal things, right? Ultrasonic is through sound waves, right? So like think about this. So this is through sound waves. How does gyroscope work? There are different kind of light sensors as well, right?
Lidar, sir. Lidar.
Yeah. So I'm talking about those sensors, right? These
Sir,
sensors,
inertial sensors.
yeah. So what do you think? Gyroscope is with that kind of a thing. So like based on inertia, based on like movement and these kind of things. Right? Gyroscope is based on the physical movement of something. So that's why in like previous classes when I was like describing about gyroscope and everything, so there's always a movable part, there's a fixed part, and based on the movement of this, they estimate the that. But this light sensors and lidar sensors, they all work based on the optics part of it. So what does it do is that it sends
Depends on light
yeah,
distance. We have
yeah.
to
So
find.
everything is based on light. So how does it work? It reflects back from an surface, and based on this reflection, if you can catch this light and everything, so based on that you can get the information that how far is the wall from you, how far is that object from you, is there any object nearby or something like that. So basic principle of object detection works through it, and not only for the sensors as well. So like our eyes work like that, right? So if I can see this computer, so how can I see it? So because like I am checking out the reflection from this like PC itself. So and from that we are estimating everything. Just a second, right? Yeah, so what I was discussing about was this. So the basic object detection or something like that. So our eyes work through those kind of a thing. So like if we have a shiny object in front of us, we can see that. How do we know that if the object is shiny or matte? If the, let's say, if the surface is rough or if the surface is very smooth, how do we know that? Based on the light's reflection, right? So if the object is very smooth and everything. So just a second. Yeah. So if the object is smooth, very smooth, the reflected light will be much with like the reflected light will have much higher intensity, right? But if the objective is matte, what will happen is that based on this, the reflective light will have much lesser intensity. So based on that, our brain thinks that, like our brain figures out the basic thing that if it's matte, if it's like if the surface is like, let's say it is an intact surface, or if the surface is broken or something like that, let's say there's a crack, something like this or something. So everything happens through this only based on this object detection, or the size of the object detection, or even based if if the object is large, object is matte, everything happens through this basic idea of this light reflection, refraction, and diffraction, right? So based on these properties, everything works. So apart from that, we also have several other physical phenomena as well. So the same thing can be done through, like, let's say if you want to know the amount of water inside an pitcher, right? So if you have a pitcher like this, inside that, and just a second, and if you wanted to know that how much water is inside that, so what you can do is that, like, what are the ways we can measure the this amount of water inside this pitcher? So there are several ways. Let me know about at least one or two. How can we measure the amount of water inside it?
Sir, by observing the length of optical path.
Yeah, so you were saying that the best and easiest answer is that we fit a sensor here, and whenever, like, we are just observing this line, whenever the water level crosses this line, we know that water is higher than that level, and whenever the water level is lower than that, we can observe the level, right? So that is kind of a more like a normal way that we can have this. Apart from that, any other options to, like, know what is FBG? Please write the full form of it. Yes, very several ways as well. So like very easy ways. Five. It's a Bragg's grating sensor, right? Uh, by using Raman effect, yeah. So these are going towards more optical ways, but like we already have got this like this camera type of sensor or something like that, which is also based on like optical methods, right? So if you are just fitting in camera or something like that, let's say the camera is not here. Just a second. Let's say your camera is just outside, something like that, right? So every other thing that, like, we are discussing right now is completely optical methods. So there are mechanical methods as well, so I am asking about those. If, let's say, we don't have an optical sensor or a light based sensor right now, so what will be the easiest way to measure this? Let don't like get confused with this, that you need to measure the exact amount of water inside it. But I am just saying that we have to maintain a level. How to know that level or something like that? What is the best way to, like, know this level or something? Yeah,
Calculating
yeah, yeah.
pressure.
How? I didn't get your answer. Can you repeat it again?
Calculating pressure.
Yes, perfectly. So, which pressure are you talking about?
Manometric.
Yes. So inside the system we'll have a pressure sensor which can measure the pressure, and based on that we can know that if the water level, or like, we obviously we need a very like huge data set that whenever the water level is this, we have this kind of pressure. So we'll have this complete data set, but throughout that we can also measure this through the pressure, right? So we now have optical methods to measure this. We now have pressure based methods to know this. So, are there any other ways? Can we not do it through like basic mechanical things? So, let's say we have a something kind of a balloon or something like that, and it has a very specific buoyancy, right? And based on that, whenever it's completely visible on top of this surface, we get to know that the level is near that level or something like that. So, it can be a very mechanical way to do this, right? Now let's move on to the actuators, like the stepper motors and everything. So, like in this case, what is the basic thing a stepper motor does is that no, the first question is like, what is the difference or what is the similarities between a stepper and DC motor? Can anyone tell me?
Sir, a stepper motor moves in a fixed increments in
Yeah,
response to the controller, whereas
steps,
DC
right?
motor is continuous.
What we are calling as steps,
Yes.
and
So,
for DC,
but DC it is continuous motion. Yes.
yeah, continuous motion, right? So that is based on their working principle and everything. So any other things?
Um,
Obviously, DC motor, if you want, like if you are giving DC motor a certain amount of movement to do, it is not that precise, right? But the stepper motor will be precise.
yes, yes, precise rotation. It's used in printers. Yes.
Yes, that's it. Any other things?
Sir, control methods.
Like, can you explain it a bit?
Sir, stepper motors can be controlled electronically,
Hmm.
whereas DC can be electrically.
Like, can you explain it a bit more like detailed? The answer is correct.
Sir, use of power alternating devices in stepper motors
Hmm.
in control methods.
So, like, let me describe it. So basically, like using a DC motor is completely electric ways. We don't need any kind of a magnetism, but to precisely control it, we need in mostly like we need electromagnetism. We also need the magnetism effect to precisely control this. So that's the basic difference between a stepper motor and a DC motor. Now, in the experiment we have seen, right, in the demonstration class and everything, the motor was brushless. Sorry, the motor was brushless. The motor was synchronous. The motor was having a magnetic rotor shaft. Right, we have seen this. So, like, what do you mean by this magnetic rotor shaft? So, like, first, let me describe it. So, like, we had like different. We have the discussion of that. So, I'm not moving into that detail. So, based on the rotor shaft, it can be permanently magnetic stepper motor. It can be a variable reluctance, and it can be a hybrid type, right? Now, apart from that, based on the winding types, we had the unipolar one and the bipolar one, right? So these are the basic things that we have already discussed. Now, tell me about this brushless and synchronous one. So what is brushless, and why is it brushless, and why is it synchronous and asynchronous? So like we know, right? For like electronic counters and everything, we have synchronous counters, asynchronous counters, and brushless means there is obviously a brushed version and everything. So what are these things? There were no that like deep discussion of these things, so that's why I am taking this. Let's move on to the next page for this. Let me leave it here. And apart from that, like just trying to answer this, and apart from that, I also wanted to like just as already discussed in the class as well. So based on digital electric pulses, they gave very incremental variations that is known as steps, right? And which are precise as well. Now, what I was talking about is like what is like I'm just telling the both the names. So one is a brushed motor and the other one is a brushless motor. And apart from that, for the synchronous ones, we have the synchronous and asynchronous. Anyone knows about these? Like what is a brushed motor and what is a brushless motor?
Sir, vaguely, I know
Yeah,
in a
yeah, that's fine, that's fine. Just
in a
try to
brushless,
answer it.
yeah, in a brush motor, the contact between stator and rotor is through a brush.
Which
Uh,
kind of a brush? Can you like tell
uh,
me?
okay,
That
brush,
is carbon
brush.
brushes. No, no, no. I'm just giving the answer.
It's a mechanical contact, or
Yeah.
yeah, mechanical
So
contact. So
yeah, so this is through a
it may generate
mechanical
EMF,
contact.
right? Mechanical, yeah.
Yeah, mechanical contact and through carbon brushes.
Ah,
Now,
carbon brushes,
yeah, yeah.
yes.
Then
And
what
in
can be the advantages and disadvantages through using this carbon brushes? And so what is in case of brushless?
in brushless, I think induction.
Magnetic induction, right?
Magnetic induction through that.
Hmm.
Yeah, I do not know. I'm not an electrical, but
No, no, that's fine, that's fine. Just
just
try to answer this, right? So
yeah.
this is through magnetic induction and that is through mechanical contact through carbon brushes.
Yes,
So
yes.
like the main thing is that if we let's say this is my phone, right, and this is my Apple Pencil. So now if I constantly touch it utilizing a brush, what will happen?
A lot of EMF gets generated, right?
Yeah,
Yeah.
and
So
through that what will happen?
it spurious signals come. Okay, yeah, I don't know.
The
Basically, EMF
efficiency
is
will
bad.
decrease, right?
Yeah, efficiency will decrease certainly.
Yeah. So efficiency decreases and anything, the
Uh,
lifespan will decrease as well,
yeah,
right?
lifespan because it's a mechanical, so we have
Yeah,
to replace carbon bushes. Yes,
yeah. The carbon brushes will get destroyed, disturbed, or something like that, and based on that, the lifespan will decrease, the efficiency will decrease. Now, that is the disadvantage, but the advantage is what? The cost will be less. Cost will be less, and even like the repairing cost will be less as well, right? Because the carbon brushes are cheap and everything. So based on that, but this efficiency is nearly of 75 to 80%. Now, in case of a magnetic induction, obviously it's better. So the cost is much higher. Now it has the issue of cost. What about the efficiency? The efficiency will increase. to a certain amount that can be used in any of the cases. So the efficiency is nearly 85 to 90%, and the lifespan will be also much higher.
By the way, one thing, sir,
Yeah.
is this motors DC motors? Am I correct? DC
Which
motors.
ones?
This brushless. Can we
Yes,
see
yes,
or
yes, yes, yes.
because why I'm asking is these days our home domestic fans also they're selling
Yes.
BDC.
Yes, we have huge, large size DC motors and everything. Yes.
Oh, so inside there is a DC motor actually. So that means they
Hmm.
convert AC to DC. Yeah, that is.
Yes, 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 yes. Exactly. Now for the synchronous and asynchronous. Like, I guess we have to change the page. Let me write it down here for now. Yeah. So, like, someone talk about this synchronous and asynchronous. What is the difference? And if you don't know about this motors or something like that, or like, let's try it. And as per the counters or something like that, there are synchronous and asynchronous. So, what does synchronous means? First, you need to know that, right?
Sir, synchronous speed.
Yes. Synchronous means in sync, right? We say that they are doing the thing at sync, in sync, right? So synchronous means they are doing it in a sync, that is in a synchronous manner. So the main thing is that synchronous is like have a matching supply frequency, or you can say that when you are just giving the response or giving the input to the synchronous one, it will work on it instantly. So it doesn't have any kind of a delay. Let me no delay, right? There is literally no delay in this case because they match the supplying frequency. So whenever we are just supplying anything, and based on that, it works instantly. So it is there. No, first let me know about this, right? And for the asynchronous, there is often delay. Right? It has some delays. Now, let me know what can be the problem with this synchronous and asynchronous. So obviously, in this case, you can see that the synchronous is better. It doesn't have any delay. For asynchronous, it have delay. Now, what can be the disadvantage in case of synchronous? What is the main problem with the synchronous? What can be the issue?
Sir, can run only at synchronous speed.
Can run only on.
Synchronous speed.
Yeah, so you are saying that we can't modify the speed and everything, right?
Yes, sir.
But in most of the cases, I'm not saying about all the cases, but in most of the cases, you need the speed that is your supply frequency in most of the cases, right? So that is still advantages. I am talking about any kind of a major disadvantage. So let's think about the power supply. So if you are supplying any kind of a power, and based on that it's working instantly, right? How can it work instantly? So like, if let's say I have this phone and this like this pencil, right? So if I am applying this power from here, the power will flow from here and then reach here, right? But it needs to work at the same time when the power is here. So how does it do that? Like, how can it do that, right? The major flaw of this synchronous is that it needs an external DC supply, or let's say excitation. Not a constant supply, but more of an excitation. So in this case, what happens is that we need to supply the phone with an external power. If I like, let's say, put the like the supply here, it needs to work at the same time, right? So whenever it travels through here and it reaches here, it needs an external supply to work at that sync, right? But in case of asynchronous, it doesn't need that because it can work with a delay, and whenever this power from here to here it reaches the phone, it can work on that. So it is self-starting. That is No excitation needed. So obviously there are several disadvantages and advantages based on your use case, based on your cost, based on your everything. You have to choose it. Now, apart from this, like, sorry. So apart from this, so there can be like other actuators as well. So what other different kind of actuators can be there?
Sir, solenoid is one actuator, which is linear actuator, solenoid.
Yes, linear actuators.
And
Anything more?
yeah, hydraulic and pneumatic.
Right. So what is pneumatic?
Pneumatic means using air pressure to drive
Yes.
piston and motion.
So what's the difference with that to an hydraulic one?
Hydraulic uses oil and pneumatic.
Not entirely oil, but like liquid, right?
Yeah, yes, liquid. Liquid means fluid. Yes, that's
Right?
not water. Okay, some fluid.
Thermal,
Hmm.
thermal or a magnetic sensors, magnetic actuators.
Sir, sir, the piezoelectric also is an actuator, right? It can give mechanical motion, small, tiny
It
one.
is
Actually,
going
mechanical
into that.
actu
Yes.
magnetic actuator or thermal actuator, sir.
Yes. Yes.
Using in MEM sensors.
Yes. 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 There can be thermal actuators, magnetic actuators.
Electrostatic actuators.
Yes. So there are
Electrostatic actuators.
yes, electrostatic. So like any kind of a thing that converts energy into any kind of a signal or something like that. So it does some kind of a work. Now, so what my main motive in this case was piezoelectric sensors, right? So piezoelectric sensors does what? With a change in the piezoelectric effect or the size of that, and based on that the response voltage changes, right? Or response current. So based on your work usage and everything, based on your application, you can change it to the current mode or the voltage mode and everything. So piezoelectric thing isn't sensor, right? But it can also be an actuator.
Yes, sir. For inkjet printers, that inkjet uses piezoelectric. I think,
Yes, yes,
yeah.
yes. So like any like other basic like daily life examples apart from this inkjet printer or something like that. Because like printer, like it's happening inside your printer. So
For example, gas lighter, our home cooking gas lighter, you apply pressure. I'm talking about mechanical one, the olden
yes, yes,
days.
yes, yes.
You apply pressure, it
That
gives
like
spark electricity. Yes.
yes, that's the best example for
Airbag
an
system.
yes.
Airbag system.
How does it work? Airbag system.
I think airbag is a very complex chemical actuation. I think.
No, it's based on your a certain level of force applied that is over the estimated limit. So like if it goes beyond an level and everything, the airbag actuates. But that is not entirely a piezoelectric sensor.
Yeah. Yes. Yes. Yes.
There
But
could be some parts that uses this piezoelectric effect or something like that, but it's not entirely a piezoelectric sensor. That
yes.
that is completely a mechanical sensor.
Yeah. Yeah. That actuation actually, that balloon blowing is due to chemical reaction. Some
Hmm.
gases come at a
Yes.
very very fast because the
Those
rate of
gases they stay in separate bags, and when that happens, the both the bag opens, and based on that chemical reaction,
yes, yes,
that
yeah, it
bag
is a
fills
kind
up.
of mini explosion happens very high
Yes,
speed. Yes.
yes,
Sir, for
right.
tire pressure monitoring.
For the
Hello.
tire pressure monitoring,
Uh,
right? But
yeah.
but then that's a sensor, right? That's not an
For tire
actuator.
pressure monitoring. Yeah. Bro, for
I
sensors,
am
no.
talking about that piezoelectric are sensors, right? So we know about several different kind of sensors, but I need
Actually,
that.
depends upon the pressure, it will change, no, sir. That's why I'm asking. Cactus actuators, tire pressure monitoring.
No, so like what I am thinking about is that when the tire moves and everything, based on that, it gives us the response that like this is the tire pressure, that much psi is inside the tire, and you need to fill it up. So it is telling
Yeah,
you that you need to fill it up. So that means it's a sensor, right?
it is sensor, but we can able to use in MEMS. It depends upon the pressure, it will change it, as like that. Data
So you are saying it
actuators.
can like also like fill it up or something like
Yeah,
that, and then it can monitor it, and based on that, it
yeah.
maintains the pressure or something like that, right?
Yes, sir. Yes, sir.
Yeah, that can be a way, but like one of the major ways that like as someone was saying, I don't know his name, but that lighter and everything, that's the most easiest way to like explain piezoelectric effect in like actuating and everything. So it's directly like giving you sparks, and because of that, the fire the fire is burnt or something like that. So like with the stove, you can use that kind of a lighter and everything. So let's move on to the question answers, I guess. If anybody has some questions regarding this, like you can like ask me. If there is none, then we'll start this.
Sir, in this course, actually more than description of sensors and actuators, I find more about fabrication methodology. I think it is too much of details which actually overpowering. Okay, so
The main aim of the course is to like know about these sensors and then try to fabricate it yourself. So this is not about the sensing and actuating part of the course. I know that like the name is a bit confusing, but the course content like is towards fabricating your own sensors and everything. So there are several courses that like work on the based on Arduino based systems and these kind of a things, but this course is mostly towards fabrication of your own sensors, your own actuators, and these kind of things.
and most of the discussion about fabrication these days is all about MEMS, right? MEMS technology. Oh,
Mechanical sensors,
yes,
so
yes,
towards
yes.
sensing and towards actuating and these kind of things, yes.
Yes, yes.
So this course content is towards that only. The name is a bit confusing, I know, but like so this that is the case here, right? So let's move on to the first question. So is it true or false? Now temperature and humidity are the main parameters in a clean room which should be monitored and maintained. Is it true or false?
True.
Yes, sir. In fact, air conditioning
True.
or air conditioners does
HEPA
that.
filter.
Yes,
Like HEPA filter.
it's true. Move on to the next one. That is question number two. I didn't have that much space, I guess. So let me write the second question here only. Question number two. That is, what is Boyle's law and what does it like describe?
I think Boyle's law is expansion with reference to temperature. Expansion of fluid. Oh, okay. Pressure. Yes. PV. Yes, yes.
No, no, no. I'm just writing the three laws here. So which one of it that expansion of fluid? What you were saying?
In response to temperature.
Temperature? No, that's Charles' law.
Sure.
This one is
So
Charles' law. Based on temperature, like if we increase the, or let's say,
Pressure versus volume. Pressure versus volume
yes,
relationship.
this one is Boyle's law. So Charles' law tells us that with the increase in temperature, the volume will increase, and if we decrease the temperature, the volume will decrease. And but the Boyle's law tells us that if we increase the volume, the pressure will decrease, and if we decrease the volume, the pressure will increase. So that's inversely proportional, and PV/nRT is the ideal gas law. Now for this, let's move it. So for the third question, clean rooms are classified by the amount of size particles in one dash of air. Fill in the blanks. What is,
Nano size of
yeah,
particles
nano size particles in,
in one. I don't
Cubic
know.
mm of air. Cubic of air.
cubic
Cubic of air.
cubic of air.
Yes, sir.
This is wrong. So are we talking about the nano size particles?
I think microns.
Yes,
Microns because nano is too small.
Micro,
Micro.
micro size
particles.
particles in a
Is very small, right? So we are talking about a very large area and very large size particles and everything. Because nano, like if there are nanoparticles and everything, and if you are talking about MEMS and those kind of things, it won't disturb that much. But if you have a micron sized particle, it will disturb obviously. Now for a cubic are we talking about microns? Inside cubic micrometer, we are talking about micron size. This is also wrong, right? The size will be much higher.
like micrometer.
Not in meter,
For millimeter cube, oh,
not in meter, micrometer, not in meters,
parts
not
per
in.
million. Parts per million. Parts per million
It
is a
is
different.
in cubic foot per cubic foot air. So per foot of like 1 foot by 1 foot by 1 foot. Inside this, we are talking about the amount of micron sized particles. So per 1 foot by 1 foot by 1 foot, we are talking about a very small size particle, that is 1 micron size particles. So now another question is that what is this size? Micron size particle means what? The radius or the diameter?
Diameter.
So why is it diameter? Why do we mean like diameter is correct.
Yes,
The question is,
yeah, because that makes sense because the width is important for covering the
yes,
chip
yes,
because
yes.
it obstructs. One
Mm-hmm.
one diameter can cover so many nanometer chips, nanometer
Yes. That's
components.
that's correct. So that's why we are talking about diameters. But whenever we use it in any kind of a equation and everything, we always use a radius, right? We always talk about the radius, this radius, that, and whenever even we are calculating the volume and everything, we are talking about radiuses. But in this case, diameter is very important because it covers the total width of the particle itself. So even if the particle is like randomly sized or a circle size or something like that, the diameter like is very important in these cases. Now for unipolar and bipolar motors, let me write the stepper motors. Stepper motors, they come under which category? So the options are, these are the types of motor, these are the kind of windings, or these are the kind of polarity.
Uh, I think stepper motors, bipolar means can change the direction, rotation.
So which of these are true then? Is it the type of the motor, the winding type, or the polarity type?
C.
You are saying the polarity, right?
Yes, sir.
No, winding.
Yes. So what does the polarity of a stepper motor mean? Is there any specific meaning of that?
Maybe when the current flows in one direction, it rotates. When you reverse the direction, it rotates in opposite direction.
What is the winding? The winding of the rotor shaft, right?
Yes.
So if it's like, so in this case, I guess we can see, right? In this case, so like I have written here the winding, but in this case you can see, right? The winding is this way, whereas in this case the winding is that way. So these are different kind of a winding. So based on these windings, there can be the like positive attraction and, just a second. There can be positive,
Okay.
yeah.
Okay.
So there can be the attraction or the repulsion. So based on these kind of a windings, we are controlling everything. So this is the based on winding. So if there are single type of winding, this will be unipolar, and if there are two different kind of windings, it is bipolar. So based on windings, if only right sided winding or something, that is only for attraction and repulsion, and if there is the opposite sided winding, that is the reverse right handed, so that is your like the repulsion one. So based on unipolar or bipolar, the types of winding changes, and based on that the stepper motor functions. So for question number 5, let me know it's true or false. So in VOC sensors, we prefer sensing layer made of nanostructured materials because, I'm just removing the true false one. Why do we prefer this nanostructured materials? Just, they have higher sensitivity at low room temperature due to lower mass. Is it true or false? I was gonna change the question, but let me write it down.
Sir, what is VOC?
VOC is volatile organic compounds, or you can also say this as the gas sensors as well.
Yes. Huh. Low temperature due to low, yeah, surface volume. Yes, I think gas, I think surface volume matters, nanostructures. For gas, low temperature due to lower surface to volume.
Yeah. So it has lower surface to volume
Yes.
ratio than films. Does it have lower surface to volume ratio than films?
Lower surface to volume.
So why do we need? So there was a question earlier. I just missed that. That was how CNT is used as sensing materials. So in that question, it was there, right? So if we have a much larger surface and everything,
Yes, if a much larger surface, the gas, exposes to more area, the sensing sensitivity goes up.
yes, so it is not lower, right?
Yes, it's
It is
higher.
higher surface to volume. So this is obviously false. Now what I was talking about is that if we have a much higher surface, but the volume is same for a thin film, right? But in case of if we have, let's say, nanostructures and everything, the total reaction areas is this, right? Let me just maybe merge it through this. So the total reaction area is this. Similarly for this is that total reaction area is increased, whereas for this the total reaction area is only this much. So your total surface to volume ratio is increased in case of nanostructures. That's why the total like the sensitivity is increased. Now to answer the question previously asked, so that how CNT is used as sensing materials. So CNT can be either, like, there can be two ways to code the CNTs. Either the CNTs can be directly deposited, that is already made thing. So like if you purchase the CNTs and then you can directly spin coat it or drop cast it directly onto your sample, that is the purchased one. Or you can, what you can do is that you can grow this. So similar, like similarly like on top of the sample itself, but similar as when you are like growing the oxide layers or depositing the oxide layer. So it is entirely similar, that if you purchase the CNTs, let's say graphene CNTs or something like that, you can directly deposit it on top of your sample. That can be through either like spin coating or any kind of a deposition techniques. And for like if you want to grow it, you can grow it as well. So there are several different kind of a techniques for that as well. Now move on to the next one. So if you want to let's say for working on a wet bench inside a clean room. What are the mandatory PPEs in case of when you are working on a clean room bench? That is the wet bench.
Uh, Goggles and gloves? Hmm? No.
Those are perfectly fine. So what kind of a gloves?
Yeah. Insensitive to chemicals. Maybe silicone.
So
I don't.
based on your use case, right? So if what you are using with, if you are using any kind of a let's say acid or something like that, then you need an acid protective gloves. If you are using just, if you're just fabricating your devices, that if you are cleaning the samples and everything, any kind of a basic nitrile gloves are okay. So you need maybe nitrile gloves, you need maybe acid protective ones. So based on you use cases, the choice of your gloves will change. No, Apart from that, the goggles one, right? The goggles one. Now for that, we don't need a goggles, right? So based on your use case, you might need it, but you might not also use it as well, right? So I am talking about the mandatory ones. What are the other ones?
Face mask.
So that is also kind of a, like, if you are using any kind of, sorry, any kind of a face mask or something like that. So the basic one is okay, face mask is okay, but what is the total dress called? The total,
Apron.
yeah. So the face mask is part of this apron, right? The face mask is part of the total apron or the total, like, based on different labs and everything. You might also have a bunny suit as well. So the total apron or the bunny suit, it also includes your face mask, your head mask, and everything. So everything is inside that. Any other things? So the gloves are one, the face masks are one. Any other things? Shoes are different, right? So based on your use case, so if you are using, like, let's say any kind of a different, like, equipment like the thermal evaporation or something like that, so you would need different kind of a shoes, and based on your, like, this is also you need the appropriate choice of that shoes. So if you are working on this weight bench or something like that, you need to protect your, like, let's say it is and VOC compound or something like that. You will be anyways working inside that glove box, not glove box, but like, inside that protective chamber and everything. So like, if it's like air sensitive or something like that, you would need a glove box, inside which you have several gloves, and inside that specific environment, you need to put your hands and then work. So based on your, like, based on your use case and everything, so for a weight bench one, you need your appropriate shoes, that is the basic lab shoes. So these are the basic lab shoes you would need. But based on your use case, if you are not like working on this weight bench or something like that, you would need any different kind of a thing as well. What is the question number? Question number 6, right? So question number 7 now. So this is also another true false one. So ISO 6 clean rooms are much cleaner than ISO 8. Is it true or false? Which one is like much cleaner? Which one is like, which one have a better cleaning methods in ISO 6 or ISO 8? Which is the cleaner version? The ISO 8 one or the ISO 6 one?
This thing we are not, sir. I think we have to go to Google because we are not practitioners. So when you're working in lab, we know.
No, so like, why
The
ISO
ISO
6? ISO
ISO
6,
6 is 6.
yes, ISO 6 is the cleaner one. Now, why
Yeah,
I'm talking about ISO 6 is that, so if I
because you
would
have
have,
to work in a precisely for more should not get more contamination means we have to go with ISO 6.
so my question, like, I can also question about this, right? Which one is better, class 100 or class 1000? So obviously it will have a clear dictation that class 100 is better than class 1000. But
Maybe related to diameter of the particles.
yeah, so there is correlation between this class 100 and class 6 and these kind of things. There are relations. ISO is the basic standard process, international standards of operation, and based on that, whenever you are going for the, like, ISO 1 is the best one, ISO 2 is the second best one, like that. So if you have a ISO base, so in India, in most of the clean rooms and everything, we talk about the class 100, class 10. So there are very few in India as well, but class 10, class 100, class 1000, class 10,000, like that. But talking about ISO is much like, is much more needed in case of R&D sectors and everything. Like we generally talk about this class 100 and class 1000 and these things, but ISO, getting to know about which is correlated with the ISO with the class and everything, it is necessary as well. So let's talk. Hmm. Now, the study of cells and their structures is known as what?
Yes, sir. Cytology. Cytology.
Cytology, right? And what is it used for?
For cancer
Yes,
studies, yeah, to understand cancer cells.
cancer screening,
Yes.
right? To screen cancer or for cancer screening. Now, then we'll move on to the next one. So, if let's uh, uh, let uh, consider a stepper motor having 240 poles. What is the what is the value of the step angle? So
Yeah.
I don't think I have written the
Maybe 360 divided by 240.
no.
So 360 by M into NR.
Why is it 360 by 240?
I'm just guessing that
No,
240
no.
poles are there. That the rotation is always between poles.
Yes. So between these poles, this is the actual answer. So how much is it? It is 1.5, right? 360 degrees. So it is the answer. But like that's why I was asking. Why is it like that? So you have a complete rotation and you have these different poles and everything, right? And based on each pole to each pole, you need that difference. So the difference is 1.5 degree for each of the like there are step angles. So you don't have any different kind of a values that is less than 1.5. So if you're moving from 1.5 to 3, 3 to 4.5 and like that. Now the last question of today's is, so this is also another like true false one. So like let me write it down here maybe. Is there any space? Yeah. So okay. So the like this is also another true false one, but this is a bigger one. So the first one is that do not enter a clean room while wearing loose clothes. Number two, removing gloves and face mask for any clean room garments is prohibited in in the clean prohibited in the clean room degowning process goes in the same order as the gowning process. And last one is So is these statements true or false? Let me know.
The statements all are true, sir.
All are true. No. So you're saying that enter the clean room, you need to you can't enter the clean room with a loose cloth, and why is that? What is the reason you can't enter a clean room with a loose cloth?
Because some of the particles should not.
What's the issue with the dangling cloth? Like let's say if it flutters or something, what will happen?
No,
What does a sudden movement inside a clean room do?
yes, there is a movement of clothes, and along with that, the body odors and everything come out. Yeah,
To,
maybe.
to avoid any kind of a fluttering in the cloth. Okay. Second one, removing gloves and face mask on or any clean room garments is prohibited inside the clean room. So it's obviously false. Then no, sorry, it's obviously true, but where do we need to do that? So
Because our body from our mouth and
that's fine. No, I'm not asking about is it true or false? It is obviously true, but where is the place we need to remove this gloves and face mask?
that is outside.
The gowning
Outside,
room, right?
outside, yes, outside room.
So we have no, that is not outside.
Yeah, gowning
There's
room. Yeah, gowning room.
yeah,
Correct.
so there's a specific room just where from the outside shoes and everything. After leaving those outside shoes, you will enter inside the gowning room, and then you will change your clean room garments, and then you can enter to the clean room itself. And
Yeah.
multiple times entering and leaving the clean room is also prohibited as well. Now the degowning process goes in the same order as the gowning process.
No, sir. No, sir.
It's
Because I
not.
saw, for example, in surgeons, no, in doctors, surgeons, theaters, the way they wear that surgeon dress and remove, they follow different. I saw that somehow. Okay.
So it's
Because,
not the
yeah,
same order, it is
yeah,
the reverse order actually.
they was-
So everything has to be reversely done. So you will leave your shoes at the last. You will first remove your gowning dress and the caps and those kind of a things, the face masks and everything. Then you will remove everything, every other thing. So everything does in a goes in a reverse order as well. Now the last one, applying any kind of a products is prohibited, because it is also true, because different kind of products, like let's say makeup, they completely relate to any kind of a contamination as well. So it can be different kind of products also. Like for makeup it is like this, there is also pencils and everything. You can't use a pencil inside it, because it creates contamination through the graphite lead or lead of the pencil, and through that the contamination occurs and everything. Okay, so this is it. If anybody have any question, you can ask me, or otherwise we'll end the session here. If anybody have any question, you can ask me.
So whether the session continues every Sunday?
Yes. So this is the ninth session, so we'll have also another three sessions as well. So like up until now, what we have, like, I haven't discussed about the clean room techniques, but I had questions about those. So apart from that, the Arduino based applications I haven't discussed here. I have just talked about the sensors and different kind of actuators. In the next one, we'll talk about different kind of tissues for biochips, phenotyping of those tissues, and then finally we'll talk about the CAD modeling of that. And the final one will be towards more advanced research and 3D printing, and how this 3D printing of sensors can work, and different kind of biosensors and these things. So these are the last three like modules of the course remaining. Any other questions? And also like in the previous class as well, so like I had a question, if you guys can see my slides and everything, because like I'm not sure, but like there's a problem with my slides as well. So like while I was uploading my slides and everything, so I was trying to check the slides through my other Gmail account and everything. So through that I was not able to access the slides. So can anyone of you confirm if the slides are visible for you guys?
Sir, in the presentation you're asking us, eh?
Mm. So like
Yes, sir.
right now the right now, like I'll convert this presentation to an PDF, and then I'll share it with you through an link. I guess from NPTEL, you guys have already got the link and everything. So I just
So
wanted to
actually,
know.
it is in a YouTube link. It was visible clearly, sir.
So the YouTube one is visible obviously, but like that's a common thing. So YouTube is a common platform and everything. So like I don't know if it's with my institute's ID or something like that, but through the institutional upload of this PDF file, that is the PPT or the presentation one. So that was not visible through my other Gmail account. I don't know if that's my Gmail's issue, or it's the common issue with everyone. So can anyone like confirm me? So like not this not in this class, but in the next class, if any one of you can confirm me, then what I'll do, if there is any issues, then I'll change the link and I'll re-upload them inside the Google Drive, and then I'll reshare that. Otherwise, like if it's working fine, then it's fine. So
Sir, can you tell me how to access these videos?
the videos are so like after the session or something, I guess within a day or two you will get a link from like an NPTEL team itself, right? So you'll get a mail, and then from that you can access my previous videos as well, or you can directly search it on like YouTube, and you can search like Sensors and Actuators live session. So you will get it from there, but the problem with that is that like I'm not sure that if the PPT is visible to everyone or not. So if someone of you can like, let me know, then I'll either re-upload the sessions or something like that, or like I'll change the link entirely. So like I guess everybody of you have gotten mail directly from NPTEL itself. So to like from which link you can access the PPTs, from which link you can access the YouTube videos and those things. Okay, so like anybody of you can just like check it and let me know.
Sir, I didn't receive any mail, sir.
Any mail like recently, or like for the entire period?
No, sir. For accessing the PDFs, I didn't receive any mail, sir.
And you received the mails for the YouTube links.
No, sir. But I received the link for this session in my mail, sir.
That's a reminder one, I guess. But apart from that, you might have received that for the accessing the previous videos and everything. So I guess either you would have received the mail, or it would be inside your NPTEL from where you are accessing the videos, right? So there will be a downward tab where it says the problem solving sessions or something like that.
No, sir. I couldn't see anything of that.
Okay. Okay, okay, then I'll check it and let you know. So what is your name?
Surya Prakash, sir.
Okay, okay, that's fine. And any other of you, if you like get the mail and everything, so if let me know if the PPT is working or not. Okay. So thank you for attending today's session. So let's meet on next Sunday. Thank you.
Thank you, sir.
Thank you, sir.